All right, so I wanted to take a couple minutes here and look at a differential equation. Kind of talk it through, kind of talk about some of the main things that are often asked on an AP exam. For AB, BC usually gets exactly these questions as well, plus then some question about Euler's method is usually the addition in the BC, but or the integration to find the equation requires partial fraction decomposition or something like that. Okay, so the differential equation, remember, is just an equation that involves a derivative, and that's what we have here. Notice that both x and y are involved with it, which means, if you remember our conversation about like when I'm constructing it, that I should see changes as I move left and right because x is in the equation, and I should see changes as I move up and down because y is in the equation. Remember that when you're sketching, so this is an aside, remember that when you're sketching a slope field, so if I would see patterns in my slope field and they look like this, remember that you are looking at, when you connect the dots, that is the solution to the differential equation. In other words, it is the antiderivative. So here's a really quick reminder, because if you would say that your differential equation is x squared, you're saying the slope is only dependent on x and that it's the x value of any point squared. Well, so that's why you'd have a positive segment here, but you look over here and go, it's instantly wrong because we're saying negative slopes. We're saying the tangent line on the curve at that moment would have a negative slope. This would never produce it. So the differential equation here is actually something more like x. Now there could be a coefficient there, we could shift it or something, but that would be kind of the general pattern here of it. And so again, the antiderivative, when you connect the dots, that is the antiderivative of the differential equation. Okay, so that is just a reminder for you about that. So coming in here now to, what if I'd ask you to draw then a differential equation? And sometimes they do this on the AP exam, that they'll give points. And usually they don't give too many points. So maybe they would give a series of like 9 points or something like that, and they would just say sketch a segment that would represent the slope field given the differential equation. And so really all you would do is you'd look at this point and go, okay, the coordinates of that point are 2, 1. So that means the slope at that point would be 2 times 1 plus 1 over 2. So the slope of that point is 2. Now you have a grid here, like you have it should be, if I made this a little bit more evenly spaced, you'd have a 1 by 1 grid. So that would mean that you would know that, following along that line would be a slope of 1, right? Thinking right here. So make it steeper, like you could even get it from the grid. They usually don't want it to be, don't expect perfection here. They're going to look for it kind of pointing the wrong way or the pattern to look wrong. What I mean by that is like if this one should be steeper, it better look steeper than this one. But you do have a grid, and usually they're not terrible values, and you kind of make it right. Okay. So then if I'd ask another point, so if we think about the point, I'm sorry, that was 2, 1. I drew that in the wrong spot. So 2, 1 is here. So that would be our slope of 2. And then so if I'm looking now for this point 1, 1, so I would put 1 into the equation for x. I would put 1 in the equation for y. And so the slope is 1. So at that moment, then I should have a slope of 1. And I could fill this in, and then so when x is 0, it doesn't matter what y is, the slope would be 0. And then so I could fill in those 9 points. And that's something that they have often asked. Okay? So the next thing, I'm gonna erase this. The next thing is to actually come up with the equation. And this is that comment I was making in class that for the most part, well, other than just kind of looking at the slope field, our strategy to actually find f of x, um, if y is f of x, so solve this thing here for y, our strategy is separate. That's it. I'm pretty sure this is the potato question, um, and other ones like that, that students will come back and say, we've never did anything like that. The context can seem strange, but in general, if I'm looking for something here about y, and I'm trying to get y by itself, I can't have y's here and think about integrating in any way. So I need to try to get them together. So we can separate, and really we're just thinking about fractions and rearranging here. So I could write something like 2 over y plus 1 dy is equal to x dx. And they're telling us this information. Remember that this is for C, and that will then put it together here to get a final answer. So integrate, and you should be working along with me. This side's easy. This side, you could take the 2 out. It's really then something like this, 2 times the natural log of the absolute value of y plus 1. And here's key. If you, as soon as you integrate, if you're separating these variables and you integrate, you now must put your c in. Do not delay. Do not wait. Do not do it later. And I would say right now is the moment to solve for c. Do not rearrange this. Sometimes you'll get the right c if you rearrange it, but in this case I can see we won't. Because if you take this and solve it for y, there's an exponential step here. And so that should be what you're thinking that we're going to go to finish this. But that means that this plus c ends up in the exponent. And if you tack it on to the end, that's going to be terribly, terribly wrong. So my suggestion, as soon as you integrate plus c, it doesn't matter which side, right? Just move the c over, but solve for it right now. Okay. So they're saying f of 4 here is 0, so when basically they're telling you a point. The input is 4, the output is 0. And so here in my equation, I'd have 2 natural log of the absolute value of 0 plus 1 equals 1/2 4 squared plus c. That's the natural log of 1. E to what power is 1, so that's 0. This is 16 divided by 2, so c is minus 8. Okay, and now I would go back to this equation. I now know what c is here, and then I can start manipulating it, because my goal now, I have found the particular solution. I found the specific point basically for the shift here, and I'm now going to solve this for y. And so we could divide everything by 2. Now is the step where we could think about either rearranging it from a log form to an exponential. I usually think about, so you could kind of use this base and say that e to that power should be absolute value of y plus 1. You could think about taking e to both sides, and these are inverses, don't say cancel. And then that would leave us with the y plus 1. It doesn't matter which way you think about it, you get this statement. Absolute value of y plus 1 equals e to the quarter x squared minus 4. And so, so do we need the absolute value bars there? So think about that for a second. Do we need them? And hopefully you just said no. If you look over here, are we ever going to, well, let me say it this way. Think about the point here that we're talking about. We're talking about a point, where did I put it? 4, 0, okay? Um, so really it's going to depend on that, whether basically, let's say it this way, that if this thing is negative, so like if I think about the absolute value of -3, wouldn't I need to toss another negative in there to ensure that the answer is positive? And so when you're thinking about that, but is this really what we're talking about? For this problem, do we really need this then, depending on the points here we're talking about? So I think I could say that better. So yeah, let me see if I can say this better. So if we would make this simpler and just say the absolute value of x equals 3, then either x is 3 or x is -3, okay? So here, if that's the case, and I think of this as like my 3, then either that is equal to the value or it's equal to the opposite of the value. So I could say y plus 1 is equal to e to the quarter x squared minus 4, or it's also possible that y plus 1 is the opposite of that. Sorry. And this one on the left is going to say that y is equal to a quarter x squared minus 4, that whole thing minus 1. And this one is going to say, so I mean, it looks like there's two solutions to this. But remember, we have a point. We have a point 4 comma 0, which means it must satisfy the solution here. Otherwise, it's not a point on the solution to the differential equation. So if x is 4, do you notice right here that this exponent becomes 0? E to the 0 is 1 minus 1, solution, true, 0. So this definitely works, which is the one that I'm saying that the absolute value bars are not needed. And now, since this is always going to be a positive number, I know this is always going to be a negative number. Subtract 1 from that, how am I supposed to get a y value of 0? And in fact, you can see that here with the point, right? Because then this becomes minus e to the 0 minus 1. Well, order of operations would say, so exponents first, right? So that's 1, that's minus 1, that's minus 2. This is not a solution then. And so because of the point that we're after, this is the only answer, okay? So that's a subtlety. I can't always speak to how the grading would work if you would have left the absolute value bars there. I would probably just, when you look at this, try to decide, is it going to be that positive or the negative one? And if you're starting with an exponential here that's always positive, that's going to make this negative, and so that's just something to maybe think through. But hopefully I said that better the second time. But here is our solution. Now, the third part of the question here that I asked was find an equation with a line tangent to f of x at x equals 6. So if I want to find a tangent at some point, well, I need the point. I need 6 comma whatever. So first step is to go to the equation we just made and figure out what f of 6 is. Okay, so f of 6 should be e to the 1/4 times 36 minus 4 minus 1. 9 minus 4 is 5, so f of 6 is e to the 5th minus 1. Okay, so far now we have a point. We have a point 6 comma e to the 5th minus 1. That's not in the exponent. If it would erase here for me. Okay, what's happening? Minus 1, there's our point. And then we need a slope. Well, to get the slope, I'm going to need to go back to my equation here. And the numbers here aren't awesome. But so here's my slope equation. But don't be bothered by that, right? Like we're just going to go with the strategy that we know. And so we're going to say then that the slope is 6 times e to the 5th minus 1 plus 1, that's y plus 1, all over 2. So that's a 3 e to the 5th. So the slope is 3 e to the 5th, if I didn't make an arithmetic mistake. So now you have all the pieces. And remember, point slope is fine. So what's the equation of the tangent line, right? I have a point, and I now have a slope. So my equation of the line would be y equals slope times x minus x1, 6, plus y1. Done. So hopefully this little primer here was helpful to remember some of the things of exponentials, of differential equations, this one involving an exponential, but they wouldn't have to. You should be able to draw a sketch of one. You should be able to separate the variables. Remember, that is our strategy. And so get the x's on the same side, get the y's on the same side, integrate. If it's y to the first, right, like that, minus 1, if it's a first here in the denominator, that's a logarithm. If this would have been a y to the negative 2, then do anything that you would normally do. So increase the power by 1, divide by the new power, all of those things. And if I ask you to find the equation of a line tangent, just think, what do you need? I need a point, and I need a slope. So with that, I hope that was helpful as you think about your work this week. I'll see you later. Bye.